Hello everyone, this is INE Foundation Lab 3 and Section 4.6 EIGRP. Okay, before I conclude this section, let me explain EIGRP concept and I will come back and conclude this section. Okay, let's start by EIGRP feasibility condition. In the EIGRP feasibility condition, we have advertised distance or reported distance and feasible distance or FD. The reported distance is metric from our neighbor to the destination. In other words, this is how far the destination is away from our neighbor. Okay, let's show this topology here. From R1 to our destination network 9990, there is two paths. One is to R2 and the other one is to R3. R2 advertises reported distance of 4,864 and FT of 5,888, and RT is advertising a reported distance of 2,816 and feasible distance of 4,096. Okay, reported distance or advertised distance are metric from our neighbor to the destination. This is from R4. There is no reported distance because it is attached to our destination network, and R4 is our last hop. There is no neighbor between R4 and our destination network. And physical distances are total metric to the destination, total metric from our current order to the destination. From R4 to our destination, our FD is 256. Then R4 will advertise its metric to R3, and from R3, our reported distance is the metric from our neighbor to the destination. Metric from our neighbor to the destination is 256. In other words, reported distance is the FD of our neighbor. The FD of our neighbor is 256, then reported distance will become 256 from R3. Then the FD will become, let's calculate this FD. So current metric from this current, the metric from this current rotor R3 from to destination will become this one. This is 2560 plus 256 equals this one. 2816 will become our FD. The total metric from this current rotor to the destination. This formula will apply to all other rotor as well, from R2 and R1. So the FD will become 2048 plus this value, and FD from R3 will become this value plus this one. Okay, to become successor, shortest metric to the destination will become successor, the successor path or successor route. In other words, largest physical distance to the destination. If I check this from R1, there is two paths. The one is one path has FT of 2096, the other path has the FT of 5888. Then the last FT will become a successor. Then this path will become a successor because it has lowest FT than this path. R1 will select this path as successor, the path with the lowest FT. And to select feasible successor, there is one condition. To become feasible successor, AD or RD of current feasible successor should be less than FT of a successor. To become feasible successor, RD of feasible successor must be less than FT of a successor. Okay, let's check this topology. From R1, the FT of our successor is this one, 4096. The FT of our successor root is 4096 because it is lower than this path. Then it will become successor. The FT of successor is 4096, and to become feasible successor, or the path to become successor, the RD of our successor, if let's check from this one, if let's check if this path will become feasible successor or not. The RD of feasible successor, the RD is this, the RD is 4864 must be less than 4096. 4864 is our RD of our feasible successor, and 4896 is our FT of our successor. To become feasible successor, the RD of our feasible successor should be less than FT of our successor. Then it is not 4864 is not less than 4896. Then this path cannot become feasible successor. There is no feasible successor in our network because RD of our feasible successor is not less than FD of our successor. This value should be less than this one. Then there is no feasible successor in this network. This is how EIGRP feasible condition feature works. And to see our feasible successor, we can use show IP algebra topology. This is the only path which pass the feasible condition. And to see all the paths, we can use show IP algebra topology or links commands instead of show IP algebra topology. Okay, this is algebra feasibility condition, and let's see the algebra feature. Okay, we can conquer algebra in two ways. One is traditional mode, and the other one is named mode. Named mode is similar to OSPF version 3 or MBGP or multi-protocol BGP. This is the new way of conquering EIGRP. Named mode or multi-AF EIGRP, it uses virtual instance name. We type virtual instance name, then we conquer our AS number. We conquer our AS number on the virtual instance name. Then it supports address family for interface or interface compression and topology compression. And also we have address family for IPv4 and IPv6. And the IGM method uses word metrics. Word metrics are word metrics use picoseconds to calculate a delay instead of microseconds. This is the job of word metrics. It uses picoseconds instead of microsecond. And in EIGRP traditional mode, EIGRP does not support virtual routing or VRF in IP version 6 implementation, but we have address family for VRF in EIGRP named mode on the IPv6 address family. And in EIGRP named mode, everything is compared at a single place on the EIGRP communication. There is no interface level communication in EIGRP named mode. This is a key difference between named mode and traditional EIGRP. Okay, the other one is the split horizon rule in EIGRP. In topology like hub and spoke, we must in most time we have to disable split horizon on hub routers. What is split horizon rule? It's a rule a router cannot advertise a route back out of the same interface upon which it was originally learned. This is the rule of split horizon. In hub and spoke topology, if this is in hub and spoke topology, in most time we should disable split horizon on hub to spoke connectivity. Another feature is third-party next-up feature. In EIGRP or in most advanced distance vector routing protocol, there is implicit next-up. Implicit next-up is sending or advertising routers addresses. And third-party next-up, in other words, it is explicit next-up. Third-party next-up allowing for pointing to a different next-up other than advertising router next-up. And this is only possible if the advertising and receiving router are in the shared segment. We can configure third-party next-up, but this command no IP next-up save EIGRP. This is similar. It is like BGP next-up save command. Okay, and this is the EIGRP concept. Mode and feasibility condition. And now let's configure this section. Okay, configure EIGRP AS 1, 2, 3 between 5, 7, and 8. Let's see the topology here. There is 5, 7, and 8. We have to configure EIGRP AS 126 between 5, 7, and 8. Okay, yeah, this is the EIGRP delay value should be measured in picosecond instead of microsecond. It means we have to use EIGRP named mode instead of traditional mode. It's in picosecond instead of microseconds. We have to use white matrix. White matrix is only in EIGRP named mode. Okay, let's configure. Sorry, now EIGRP named mode. Let's start by 7. I have to specify return instance name, config T, route EIGRP. This is our return instance name, so EIGRP name member conversion. This one is for traditional EIGRP and this one is for name mode EIGRP. Let's type. This is AS 200, this one. Then I will go on address family. There is two address families. One is IPv4, unicast. Then I have autonomous system, and here I specify AS number here. Then I have this physical address, which is this one, into our EIGRP network. The network is okay. To advertise our network, I have to go topology based address family. Unicast. Here I have topology. On the topology base configuration, or I have to specify network. Network. Let's see where it is. Okay, this is this network here. Okay, the to advertise network, the network command is on there. IPv4 address family, not topology base. This is Just add this family, then here I can specify network. Advertise network. My network is this one. Zero. 0, 0, 0. 255 wildcard, please. Okay, this is the same one on what has to show down. Tab section. The EIGRP. This is our virtual name. Then I have specified this network. Copy. Config. Okay, then this one I will have show EIGRP. Then add this family IPv4 and specify our neighbors. Then I have these two neighbors from 7. This is new. This is the new show command for this family. Show EIGRP this family and IPv4. We have topology and interface seeders. Show API interfaces. This is one interface. This is shared network. Okay. Okay, interfaces for this one. Show IP, show EIGRP, IPv4, add this family, IPv4. There is no EIGRP IPv4 root yet. You can see topology video. This is our topology. Interfaces. Okay. Okay, now redistribute loop pack 0, 5 and 8 into EIGRP. Okay, I will use a root map for distributing our loop pack of 5 and 8 into EIGRP. Exit, clear root map. Tab, connected to EIGRP. and match interface and loopback 0. Show down section dot EIGRP. Then I go to virtual instance name, add this family. Okay, it is to redistribute into EIGRP. I have to go into topology based configuration. Topology base and tap redistribute. Connected. The root map and specify a root map name. Okay, let's do the same on 8. I have to create a root map. And go to this one. Then go to topology base and R type redistribute. Connect the root map as well with map name. Okay, now let's verify another 5 for the show EIGRP. Show EIGRP. Add this one on the IPv4 unicast. IPv4 unicast. Authorization system number is 123. Industry. IPv4. Okay, let's do show IP root EIGRP. Okay, just show IP root EIGRP. Then we have external EIGRP external, because I have redistributed this loop back into EIGRP on 5 and 8 via this 5 and 8. So this is done. Okay, now Advertise gigabit Ethernet 1.55 on 5 network into IGRP, and 7 and 8 should see this summary instead of. Okay, here I have to use summary address to Advertise /23 instead of 24 on R5. Okay, let's bring this R5 here. I do show down power section to EIGRP. Then I'll go to EIGRP mode, add this family. Then I'll advertise this network. Do show IP interface for if. Then I'll advertise this network. Network 000.255. This is 24. Then I will go to interface. Okay, for EIGRP management mode, there is no interface configuration. I have to go add this family of interface. This is AF interface command. Let's go to this AF interface. And specify this is this network. Now you can use your summary. Add this command. This is on the AF interface configuration mode. Summary address 128 10 55 54 0, and it should be 255 255 254 instead of 255. Oh, summary address 23 is summary address. Done. Now let's show IP UTIGRP. Now I have the summary address. Show IP root EIGRP, and this is our summary address. And the EIGRP delay should be microsecond, and this are configured in named mode. And Authenticate the EIGRP control plane using this HMAC SHA 256 with password of this one. Okay, we have to use authentication. Okay, for concrete authentication, I have to go AF interface configuration mode, AF interface, and this interface is this one. Interface brief, AF interface authentication mode should be this one, and the key must be EIGRP. I have to do the same one on the it is 150 AF interface. I have to select this interface and type this one. Same one for config. What is add this family AF interface command and type this value. Now let's show your GRP. Add this family IPv4 neighbor commands. Then I have our neighbors and working. So this is done. And the last part is R5 and 8 should not form an EIGRP adjacency, but they should still see each other roots. Okay, I can achieve this goal by using neighbor commands. This is like urban spoke topology. I can achieve this by using neighbor command here. Here it says 5 and 8 should not form an EIGRP agency. 5 and 8. Let's check this 5 and 8. Show IP. Show your GRP. Add this family IPv4 unicast. 4 neighbor. At the moment, R5 is forming neighbor with both 7 and 8. Then I have to use neighbor. It should be only be neighbor with R7 or hub, not R8. It is like hub and spoke topology. This is hub and our spoke. Okay, let's configure hub config we show now hub section okay EIGRP yes add this family and there is neighbor here on the network command. Specify the approval neighbor. Okay, neighbor. One 28, 10, 123, and 5. On top. This one. And neighbor 5. Of the 5 and the other one is 8. Okay, on here we show on pipe section IGRP. On here I have to go on the hotel IGRP address family. Config. Then I have to go on the AF interface on type. Excuse me, there is no here on the address family configuration. On the address family, I have to specify maybe it should be 7. Same on same on 8. I have exit and I have to specify neighbor. Okay, now let's check our hub and spot topology. Show EIGRP address family IPv4 and type neighbor. From hub, from R7, I have 2 neighbors. And let's check here. And from our spoke, I only 1 neighbor. And there is one last thing I want to mention. This is split was a rule. The router cannot advertise the route back out of the same interface upon which it was originally learned. For this reason, I have to disable split was on hub. If I ping 128, 10, 123, and 8, Okay, so 128. Okay, sweet. 888. There is no connectivity spoke to spoke. Because why there is I have to disable this spread horizon rule. Sheesh. 5. This is spread horizon. Show this picture. It says the router cannot advertise to back of the same interface upon which was originally learned. Okay, yeah, R5 is R7 is connected with 8, but it cannot go back to R5 because its spread horizon is enabled. I have to disable it on this on the other interface AF interface command. Okay, let's go to R7. Showdown pipe section. Go to EIGRP config T. This one. Add this family. Then the AF interface. I tap no speed horizon feature. Then if I test with this one, now I have connectivity. The connectivity from R5 is R5 now is going to hub, then it's using spot. Same as here. Test with 5555 and she's done. Okay, to make sure that R5 and RH can should not form any algebraic adjacency, we have used neighbor command and disable a split horizon on a hop. This split was on hop water for spoke to spoke connectivity. Okay, that's it. I hope you have enjoyed this video and thank you for viewing.